Okay, so let's go ahead and get started. Today we are going to talk about tables for a while. We'll talk about static tables to start, and then we'll talk about interactive tables with a package called Reactable, which I think is a really amazing package. I'm very impressed with it. And there's a newer package called Reactable Formatter that is also super nice and really helps to, oh yeah. So this, before we really get started, these are the books that we will have for our data viz competition. So the winning group, we have 3 of them. So I think we have no group that has more than 3 people, right? So great.
Yeah, it's a super enticing book. Hi, my name is Ian Winbrock. I'm with the Center for Science Communication Research. We're an interdisciplinary research group on campus, really fomented and founded to increase, hello everyone on Zoom, interdisciplinary science communication research. And part and parcel of that research is the way that we communicate data and communicate research findings. The Truth for Art, fantastic book, and it really kind of espouses some of the methodology and research approach that we use on campus when doing interdisciplinary science communication research. So yeah, just another kind of way to entice y'all for your project. And although she can't be here, Dr. Ellen Peters is just super excited to share this book with y'all and really looking forward to the competition and seeing what y'all come up with. Great. Hey,
Great.
Thank you so much.
Yeah, thank you so much. Sorry, we're off to kind of a rocky start. I forgot he was coming. So this, Alberto Cairo is the author of this book. It is super good. I highly recommend it, even if you are not competing in the competition or aren't part of the winning team. It's definitely worth checking out. And Ellen Peters, who he mentioned, is also going to be one of the judges. So we'll have Ellen Peters and then a woman named Poppy something from USA Facts, and then my friend Allison Hill, who used to work for our studio and now currently works for IBM. She does amazing stuff. So she will be joining us as well. They'll all be on Zoom. That was actually one of the topics I was going to talk about, but we'll just talk about it right now. Next week, we will I have this little flyer. I think I sent it out on Canvas, so you've probably all seen it. I put it together in like 2 seconds. It's not like super fancy, but next week, notice I say from 2 to 4 p.m. is when the actual competition will be. So we have 2 groups who opted out of the competition. So everybody in this class will still be expected to be there from 1 to 4. And you don't have to be there physically if you don't want to. I would encourage you to be, but if you don't want to, that's fine. There is a Zoom link down here and you can present from Zoom. So that shouldn't be a problem if you would prefer to be at home or wherever you want to be. Okay, but we will be in Headco 142 next week. So it will not be here. It's over in Headco over that way. Okay. So again, the groups that opted out will present from 1 to 2. And then the remaining groups will present from 2 to 4. I put on Canvas, I think, roughly 20-25 minutes for your presentations. Okay, so if you have 3 people, that's like maybe 6-7 minutes each. So it sounds like a fair amount of time, but it's really not that terribly long. If you go over a bit, like, it's not going to be a problem because we have 2 hours and I think we have 4 groups, so we should be fine. We just need to make sure we have enough time each time after you present for people to ask questions. This is open to the public, right? So the 2 to 4 p.m. part, not the 1 to 2, but 2 to 4 p.m. is open to the public. So I have invited the entire College of Ed. I don't know how many people will attend, probably not too many because it's week 10, right? And people are busy, but we will probably have a few people at least that attend via Zoom and maybe a few people that attend in person. So that's why we're at a different classroom for 142, just in case we get a bunch of people there. Okay. there were not any planned treats or snacks, but we could arrange something if you all want to do something like that. Do a Errol with the heartbreaker. Yeah, so we can maybe plan for something. I can put something together like that. Any other questions about it? Yeah.
So for the presentations, do we just show our visuals, or does it need to be in the dashboard or the blog format?
Yeah. So on Zoom, in case you didn't hear Javi, she was asking, does it need to be in the dashboard or blog format, or can you just present your visuals? This is expected to be a work in progress. So this is week 10, not week 11, right? So you still have time after you finish this to either address feedback or finalize things like that. I would ideally like you to have at least it be in a rough draft of the format that you're going to have it in. It doesn't have to be, that's not required. Okay, so what is required is that you have 3 visuals that are all but finalized, right? So they should be pretty close to your final drafts. There might be 1 or 2 things that you're still trying to do that you haven't done. And then you can go through those. If it's already in at least a draft of your dashboard or your blog post, that's just like bonus points to me. So I'd really encourage you to try to do that, but it's not required. Does that make sense? Yep.
And another question is, like, do we just go about it as a class presentation, or do we do something extra, like the groups who are participating in the competition, do we do something extra?
Yeah, okay, so again, I'll just repeat it for those of you on Zoom in case you couldn't hear. The question is, if you're part of the competition, do you need to do anything extra that you wouldn't do as like part of the normal class competition, right? And so no, is the answer. The presentation should be pretty much exactly identical. So, you know, the only thing I'll say that might be a little different is if you're in the competition, you might want to focus on your final visualization just a little bit and a little bit more, I mean, because really what I want for the presentation is to not just see the final product, I want to see your journey to the final product, right? So that's why if you look at the requirements for the final product, that you have to have previous drafts that are shown in there, right? And so you could do that through tabs, or like if it's a blog post, just scrolling down through the blog post, or different pages or whatever, right? But I want to see not just the final product, but the previous versions too. And so if you're competing in the competition, you might want to spend a little bit more time on your final product. But either way, I want to know not just like what you're proud of and what you're happy with, but also like what were the things that were frustrating, and what were the things that were hard, and what were the things that were hard and you were able to figure out a way through and you were happy about. And very likely, because this is still expected to be a work in progress, there could be things that you're like, and this line is still here and I really want it to be here, but I can't figure out how to get it there, right? And that's totally fine too, to be like, you know, these were the things that I was struggling with that I was able to figure out and I was happy with. There's still these couple of things that are left hanging that I haven't quite been able to figure out yet. Any other questions? Okay, I hope it's a fun thing. This is the first year I've ever done this. And since I'm moving on to a different job, it'll be the last time I ever do this. But it is meant to be like a fun thing. It's not meant to be super high stakes or anything. It's just really, every year we've done this, I've been so impressed with the visuals that people produce at the end of the term. And so the first year I was just like, wow. And then like, you know, that was like the first 2 years, I guess. And then last year, I did like a Twitter thread where I like shared everybody's who was like willing to let me share theirs, and tagged people on Twitter if they were on Twitter. And that was kind of fun. And so this is kind of just taking it to the next level after that. And so I'll probably put together a Twitter thread also if you all are okay with me sharing your project. So I'll probably just need to get it okay from you if you're okay with that. But yeah, I've always been super impressed and it's really fun. So this is a way to kind of just celebrate with everybody instead of just us or just me rather. So the agenda for today is, first, let me get there. We're going to start by reviewing the homework. Okay, so we're going to go through all of the homework and you can ask any questions that you want to ask. Hopefully everybody has turned it in by now. If not, then I'd ask you to log off while we do that. And then we'll talk about tables. As I mentioned, we're going to start with static tables. And for that, we're going to talk about GT. GT is a really powerful package. The one that you maybe are more familiar with is called Cable Extra. Cable Extra is very popular. And because of that, I'm covering GT. So Cable Extra, a lot of people have at least some familiarity with, and GT, a lot of people haven't experienced it all. And I think it's just as nice, if not nicer, than Cable Extra. Then we'll talk about Reactable, which is for building interactive tables. Okay, so this will be, this will take a little while to get through all of that, but not like hours. And then we'll probably take a break after that, and then we'll come back and we'll talk about geographic data. Okay, geographic data is a gigantic topic that there are courses on right in the university. And so obviously we're not going to be able to cover everything. Where my hope is to give you a quick introduction and get you at least comfortable in producing basic maps and get you an idea of where to go for more resources to learn more, and some possible packages to explore. Okay. So we'll talk about vector versus raster data, producing basic maps, and then we'll talk about sort of the geospatial ecosystem in R. So for tables, so we have sort of two separate learning objectives. For tables, the main learning objective is to be comfortable with the basics of GT. So you should be able to create a table. We will create tables today together. Format columns, create spanner heads, etc. Right. And then for geo, we'll go over this more when we get there, but like basically understanding the difference between vector and raster data. If you remember when we were talking about saving plots with ggplot, it's the exact same sort of thing, vector versus raster. Okay. Be able to produce some basic maps using a variety of tools in R, and be able to obtain different types of geographic data. So we will mostly talk about obtaining vector data, but we will talk a little bit about some raster data, specifically like elevation data, which can occasionally be useful, but not super often in my experience anyway. And then we'll also talk very briefly about ways to create interactive maps in R. There's a lot of different ways to do that at this point in R. It used to be that Leaflet was about the only way that I know of anyway that you could do that easily. Now I'm not even going to talk about Leaflet because there are other packages that are much easier. Okay. And then, yeah, basically just understand the basics of the R geospatial ecosystem. Okay. All right. So that's what we're going to do today. But first, we're going to review the homework. All right. Let me get there. This is not what I want. This is what I want. Okay. So here we go. This is the homework, right? And for this homework, we were using Tidy Tuesday data again. And we were looking at transit costs, right? And so this data was from Tidy Tuesday, but is also available through Kaggle. When you get to the machine learning course, you will probably work with Kaggle a bit there too. It's a platform for basically machine learning competitions. So they have some prediction that you're supposed to make, and then, but you only get a small piece of the data, and then you build a model, and then you just, and then you make predictions for all the other data that you can't actually see, and then you get a score back on how accurate you were. Okay, and so sometimes there's like big competitions on Kaggle. We can go look at it real quick. Oops, I'm not even sharing my screen yet. On Zoom, sorry. So Kaggle looks like this. And so it's a really neat platform. There's a lot of discussions where you can just learn stuff. Apparently they even have courses now. I didn't know that. And so it's a really neat place that's worth exploring. But these data that we're going to be looking at came from Kaggle originally, and then they were converted into a Tidy Tuesday, competition there, not competition, but whatever. And then, oh no, sorry, I'm wrong. The crime data came from Kaggle, and then the transit data came from Tidy Tuesday. Okay, and then there was the opportunity for extra credit with Git and GitHub. I've graded a fair number of yours so far, not everybody's, but I've noticed quite a few of you doing that, which is great. I loved seeing the branching and the issues being filed and all that stuff. So that all looked good to me. Okay, so to get started, we were going to get the transit data. So you could either do this through this Tidy Tuesday R package, or just read in the data from switched my panes around. So I just ended up reading it straight from GitHub. Okay, and then for the first question, let's go over here. You are supposed to, just a sec. Okay, so for the first question, you were supposed to replicate a plot that looks like this, right? And so I said that you should probably use this country codes data set to get the actual names instead of the abbreviations. All right, so that's what we're going to do. Okay, so I'm loading all my packages here. I'm loading tidyverse, lubridate to handle dates, ungviz because there'll be some times when I want to make color with the text in the subtitles. Dviz sup, I don't think I actually use that. I could probably get rid of it, but I'll keep it in there just in case. And then, oh no, ungviz is for different things. GG text is for the colors. Ungviz, I'll show you when I get there, but it's another one by the same guy. So we load all those, and then we're gonna set our theme for the for this homework, right? And so I tend to use theme minimal. This is the base size of the theme argument, so I go with about 15 usually. And then I like to put this on there. It's totally optional, but it's plot.title.position equals plot. That's what's going to left justify the plot title instead of having it like directly over the plot. Okay. Then we're going to read in the crime data. I already read in the transit cost data. And from country codes, we're going to get this code list data set. It looks like this, right? And then from there, we're going to read. I'm going to select the country name, which in the data set is country name EN, right? English. And the country, which is ECB. That's going to be the like abbreviation. Okay. So then country codes now looks like this. We just have the country name and the country. Okay. And then I'm creating this non-numeric thing. And the reason is, if you look at non-num, actually, let's just do this. I'm going to bring out that line for a second. If I take transit cost, and from the readr package, I use this parse number on real cost, because if we look at real cost, or look at transit, you can see real, where is it? I'm sorry, this is, I usually work on a really big screen, and there it is. Real cost, see how it's a character? And so we need to convert that to numeric somehow, right? So my favorite way to do that is the parse number function in readr. And part of the reason why is because if I just do that, I will get a warning, and it said 5 parsing failures, roll call expected actual. So it expected a number. So it was on row 538. It expected a number, and instead it got AVG. Okay. On row 539, it expected a number, but it got median. Okay. So what I'm going to do here is I would just go transit cost, and then I'll just like, well, I could do it with dplyr. I'd go slice, and I'm just going to start at 538 and go to 550. I don't know, whatever. Right. And so 550, that's too far, apparently. Apparently that's not working. All right, so instead, because it's not that far down anyway, I'll just go view transit cost. And then if I scroll down here to the bottom, you'll see 530. Oh, did I already take care of this? Oh, right. Yes. Yes. Okay, there we go. That's it. That's why I couldn't see it before too. Okay, so we have on the real cost, they're mostly numbers, right? But we get to this row and now all of a sudden we have AVG, median, STD, right? So this is the average real cost. This is the median. This is the standard deviation. This is the minimum. So that's not really what we want, right? We want to drop those. These are all like summaries of the previous rows. So what we're going to do is the way I did it anyway, and there's plenty of ways you could do it, is I'm going to actually remove those rows, right? So parse number, if I just do it like this, that's going to be fine because what it's going to do is it's just going to code those to be missing NAs, right? But I want to actually remove those rows just to be careful, just to be extra careful, right? So what I did is I created this vector, which I'm calling non-num, non-numeric, right? And then I'm just saying, okay, filter transit cost where the real cost is in non-num, but then I have this exclamation point. So this is reversing the whole thing. So this is basically saying where real cost is not in non-numeric. Okay. And then I do that mutate, and then I'm just going to left join it with country codes. Okay. So I've seen a lot of people using base merge rather than left join, right join, inner join, full join from dplyr. I would really encourage you to use the dplyr ones. Base merge is fine. The issue is it's just not as explicit. And so you may be doing an inner join when you think you're doing a full join or vice versa. And so I think the dplyr ones are quite a bit nicer. The other thing I've seen is a lot of people doing full joins. I would encourage you to not do full joins unless there's a very clear reason that you need to do a full join. Most of the time, you have a primary data set and you're adding things to that primary data set, right? If that's the case, you want to do a left join. I do left joins probably 80% of the time at least, okay? If there's really two data sets and you want to keep everything in both of them, then you would do that full join, right? But most of the time, you're going to have a primary data set that you're just adding things to. And this can be really important when you get with larger data and you're working with a relational database that has hundreds of tables. If you're doing a full join every time, your ending table is just going to be completely gnarly and unworkable. Okay. So I'd really encourage you to start to think about that. Okay, so here's transit, right? And then what I'm going to do is I'm going to compute the mean. So I'm just going to compute the mean by country name. So I'm going to group by country name and I'm going to summarize. The first thing I'm going to do is compute the n, okay? And this function is from dplyr, so it's just n like that. And that's going to give me the number of rows in each country, okay? Then I'm computing the mean of the cost, the standard error of the cost, and then I'm computing the lower and upper bounds. Notice with the lower bound though, I first compute the lower bound and then I say, okay, well, if the lower bound is less than 0, then just make it 0. Otherwise make it the lower bound, okay? Because we know that the cost can't be negative. So it doesn't make any sense for that error bar to extend into negative, okay? So I do that and I get a data set that looks like this. Let me see if I can pull this up a little bit. Okay, so that looks good. And then I asked you to filter to only countries that had at least 3 observations. So I'm filtering to where n, which is right here, is greater than or equal to 3, right? So I do that. And then I'm dropping any row that has NA for the country name. I'm not sure if there are any. And then finally, I'm going to reorder country name according to the cost. Okay, so this is just a factory order so that they will follow the axis correctly, right? They'll be in like descending order. Okay, so transit means now looks like this. Country name and cost mean, cost standard error, and lower and upper. Okay, so you can see there is one additional column there for upper. Okay. All right, so now we're going to go about computing this or creating this plot. So we've created our summary data that we need for this plot, and now we just need to compute or create the plot. So I'm going to first put cost mean on the x-axis and country name on the y-axis. Then instead of geom error bar, I'm going to use geom line range. And you can see that here there are those ticks, right? So you could also say height equals 0, and that would do the same thing for geom error bar, but this is just a slightly more efficient way. And then for that line range, I'm saying the x min is the lower and the x max is the upper. Okay, so let me this out there. Okay, and that looks like that. Can you all see that on Zoom? Okay, I'm not hearing any objections, so I'm assuming you can. All right. And then I'm going to add the point on there, right? That looks like that. And then I'm just going to do a few more things. So on the x-axis, I'm going to say scale x continuous. I'm going to change the names of it. And if we look at the labels here, I want to just make this into, I want to add commas to them. I probably should have done scales dollar because it is cost, right? So we could do that instead, but I did comma. But either way, so here it is in dollars, right?
Hi, Daniel. Could you just zoom in a little bit? It's just collapse.
Yeah,
in
so
our-
that was why I was asking if you could see it, because it is zoomed
Yeah.
in. I just wasn't sure if you all could see it. So there. Now
Okay.
can you see it?
Thanks.
Okay, great. Okay. So and then we add some labels, and then finally, in the theme, you know, these horizontal lines aren't super helpful. You know, you might think that they're kind of helpful. Maybe they are because you can very clearly track which country, but I just decided to take both of those off. So then we're at there. Okay. Any questions on that one? This is kind of smushed because it's too big for my current size. Maybe I'll go change that real quick so it's a little bit smaller. There it is. Go down to 10 point. Okay, and then come down here. Try rerunning that. There, that looks better. Okay. All right, so then question 2, I asked you to visualize the same thing, but displaying the uncertainty a different way. I saw numerous people did the multiple error bars, which I think is great. They many of them looked really good. I chose to use the stat confidence density from the UNGViz. So these are those density stripes, okay? So I wanted to do this with the CVidus color palette. And I knew I was going to have 2 colors, basically the point and then the density stripe. Okay, so I created a palette here for the colors, which is just the first 2 colors from the CVidus, however you pronounce it, palette. Okay, and they look like that. And so what I did then is when I went with my stat confidence density, I said the fill is equal to this first color. Okay, so let's just do that to start. Okay, and that looks like that. Pretty different. Okay, and then instead of doing points, I decided to do little teeny line segments. Okay, so for the y-axis, I had to change it to numeric, but I had the country name and minus 0.4 as the y. So this is like the start point. And then the end point was as .numeric country name plus 0.4. Okay, so this just makes it a line instead of a doing geom point. Okay, and so then I had the x and the x end just equal to the cost mean, And then I put this as the second color in that palette, okay? And when we do that, it looks like this, okay? Notice this one's way up here though. Our x-axis is messed up here. So we'll hopefully fix that soon. Okay, and then scale x continuous. Notice I am changing the limits here. Again, I should probably change this to dollar instead of comma. And that looks like that. Yes, we did fix that. That's good. Okay, and then just changing the theming stuff again and adding labels. Okay, so that was the plot that I went with. Any questions on that one? Okay, yours obviously could have looked different. Okay, for the next one, let's go and look at what it is supposed to look like. It's supposed to look like this, right? So this is where we're using GG text because India is this color, which is a similar color to the points. It's actually the same color, but it never really looks like the same color. You have to make this slightly darker to make it match exactly. But I didn't worry about it. So I asked you to compute the mean length and real cost by city and then reproduce that plot. I said, look at scale sized bind as a hint. Okay, so what I'm doing here is I'm creating another object called PD2, plot data 2. Okay, so I'm taking transit again. I'm grouped by country name and city. And then I'm summarizing to get the N, the mean length, and the mean real cost. Okay, and then I'm going to use that to first just put the mean length on the x-axis, the mean cost on the y-axis, and then add a layer of points. But when I'm adding the points, notice I have in my aesthetic, the size is equal to the N. So again, if we look at this, this is going to be, this N is the number of transit systems in these countries, cities, in the cities, right? So we're going to make those points scale by that. So this is what it looks like initially. And you can see all the points are jammed down here at the bottom. So we'll deal with that in just a second. But then I wanted to add an additional layer that's going to just highlight India. Okay, so I said, same thing, geom point, size equals N. But now I'm changing the color for this one. And for the data source, I'm just filtering PD2 where the country name is equal to India. Okay, so I do that. And it looks like this. Okay. And then I didn't like that this goes from 10 to 20 so quickly. So I switched that so that it goes 5, 10, 20. And the way I did that is through scale sized bind, right, which I gave you the hint on. And you just change the breaks on it. So there it is, 5, 10, 20. Okay. And then to account for all of the points being jammed down here at the bottom and at the top, I'm doing a log 10 transformation to the y-axis. They're still jammed down here at the bottom. So then I did a log 10 transformation to the x-axis. And now it's looking more like this. Okay. And then I wanted to actually add in the name of the city on here. My guess is this is actually going to give me an error. I have a hard time working with this interactively for whatever reason, but we'll try. It works when I actually render it, but yeah, so I get this error. But this is the code that should work, right? So I'll just talk through it and then we can look at it. But from the GG repel package, we would use geom text repel. What we want to label is the city, okay? And then I have the minimum segment length to 0. That's going to give us these lines. So each of these should have a line going to their specific point. So there's no confusion, right? About which, because some of these are pretty close, right? And so I like using those lines to make sure that we know which one is represented. Okay.
Does the value represent like length equals 0? Like if I put 2, what does that mean?
It's the minimum distance before it will draw that line.
Hmm.
And so the distance is, I'm pretty sure, going to be dependent on your scale here.
Right. Okay.
So by default, it's small. I don't remember what it is, but it will only draw that line if it's if it's less than the minimum segment length. Okay, and then the last step is just to say filter where the country name is India. So so notice the label is the city, but we're filtering only to the data that are India. Okay, I want to try one thing real quick. I wonder if I just actually load the library and then take this off. If that will work. Probably not, but it's worth a shot. Every once in a while there are, yeah. I don't know why I'm getting that. I wasn't getting it when I put this together, and then as I went back to check on it, I was. So it's very strange. Anyway, so finally we're going to add the labels. And so for the title, it's just this thing. But for the subtitle, we want to make India that color, right? So this is just like basic HTML code with some, this is actually CSS code in here. We're saying the style for this span is going to be this color, okay, for India. And then notice when we come down to our theme, then we say plot.subtitle because this is the subtitle. We say element markdown, and that all comes from the GG text package, okay? And then that will, that will give us this, okay? All right. And unfortunately, I'm probably going to end up with the same sort of thing. I can knit it and it will work, but I'm going to end up with an error on this one too, I think. All right. So the next one was to do this. So basically, this isn't the idea of this. I'll be able to do everything except the labels with GG repel. But I wanted you to try using GG force to create this outline and annotate it like this. So that was the point of this one. The plot itself is pretty similar, right? We're just going to be using United States this time, and then I changed the color to a different color. And so that looks like this initially, and then we can do GG force geomark ellipse. And here I'm saying the group is the country name and the label is the country name. I'm not sure if we need the group equals country name. We might. The expand is how far that label is going to expand out. So I'll change that value here in a second. We'll look at it. Color, I just said pink. Label color, that same blue that we have up here for our points. Okay, and then contour color pink again, and then we're just going to filter the data where it's United States. Okay, so that looks like this initially. Okay, and so let's change that expand. Let's say 5 millimeters. Okay, just to be really dramatic about it. Okay. And see how this is further out now from those points. All right, so let me change that now down to like 0.1 millimeters. Yeah, see how it's trying to be as tight as it can now. So that's what that expansion is, and 1 millimeter seemed about right to me. Okay, then the label part, this is the exact same, but we're going to just use label. I'm going to comment that out for now because it's not working for me. And so, but that's going to be basically the same. Then we'll do our scale sized bend, scale Y log 10, scale X log 10, and then title and caption. Okay, so after I do all of that, it will look like this minus the labels. And then for the labels, right, we just, instead of using GG text repel, we do geom label repel, and everything else is the same. Okay, we also do have a few more arguments in there that you can add, like this label.padding, which is again just how close if we look back over here, how close these outlines are going to be to the actual text. Okay, so you can make that bigger or smaller. Okay, questions on that? All right. And finally, for the last one, we have where I was asking you to fit this model, right? And then tidy the model, and then use this PP points. And basically I'm trying to get you to move away from, I can't get this thing to zoom out now after. Very strange. I'll just refresh it. Okay, just do it this way. So basically, rather than having a continuous distribution, we go to these more discrete distributions where each of these balls or circles represents 5% probability. And so it's a way to discretize this continuous probability distribution into something that you can kind of count a little bit more. Okay, so in this case, I was comparing Regis to Barnum, and then I asked you to compare Barnum to Barnum West, I believe is what I did. Yeah, compare the Barnum neighborhood to Barnum West. So the example I'm going to go through here is actually still using Regis and Barnum because they're like, it's like the process is exactly the same either way. It's just, there's one slight difference that I'll show you. Okay, so this part's going to be exactly the same. We're going to create our model data, which looks like this, right? Offense ID, offense code extension, whatever. And then basically all we're doing is we're taking the neighborhood ID and we're going to re-level it so that Barnum is our reference group. Okay, that's what that's doing. Then we're going to fit our actual model where is crime, and you know, the focus of this class is not on the modeling. So if none of this stuff makes sense to you, that's totally fine. It's not expected to make sense to you. If you've taken a class on, you know, regression, then it probably does make sense to you, and that's great. That's a bonus, but it's not something that was necessarily expected. It's more just, this is what we're using to get to the ultimate place we're trying to go. Okay, so is crime is what we're predicting. That's a 0, 1. And we're just using the neighborhood ID as our predictor. Okay, for the data, we're going to use this model data. So that means the intercept is going to represent the estimate for Barnum. Okay, and then the family is binomial. Okay, so we do that. It takes a second or two. Taking longer than I remember it taking. There it is. Okay, and then we're just going to tidy it with the broom package. Okay, and the thing that's nice about this is it gives us all of the estimates, the standard errors, the statistics, and the p-values. Right, and it gives it to us in a nice data frame in return, so we can use that to plot it, which is what we're going to do. So then I said divide the probability space into even bins of your choosing. For example, for 20 bins, I would do this, right? And that's just going to take the space from 0 to 1 and divide it up evenly into 20 different places, okay? So then we're going to create our plot, okay? So let's see. So for Regis, right, I would take my tidied, which is here, right? This is data set. And I would filter where the term is equal to neighborhood underscore ID Regis, right? So Regis is the actual neighborhood. And so we can do that like this, right? And then to understand how we can cut up that probability space, we would say, okay, what if we randomly sampled 20 observations, right, from this equally spaced interval from 0 to 1, from a distribution that had a mean according to our estimate for Regis and had a standard deviation equal to the standard error for Regis. Okay, and when we use Q norm here, we're basically transforming it from probabilities back to the original scale. Okay, so here we go, which in this case is log odds because we're doing a model, but in some cases that can be very helpful. Okay, so then we're going to finally, we're going to end up putting these in a data frame and we're going to plot it. Okay, so this is the last part now. Go ahead and plot it. So here's my Regis, and what I did here is I'm creating a thing that I call balls, which is exactly what I just showed you, right? 20 observations from distribution that has a mean according to the estimate and a standard error deviation according to the standard error. Okay. And so then after that, so this is just going to look like this, right? There's the 20 observations, right, that we're pulling. And then I'm saying, okay, higher crime. If balls, this column, is less than 0, then Regis is going to have the higher crime. Otherwise, Barnum has the higher crime. Okay, so I do something like this, and it just looks like that. Which place has the higher crime, according to our estimate? Okay, and so we now have that data frame, and we can use that data frame to plot it. So again, the purpose of this is to understand the uncertainty in this. So if we were just to look at the point estimates from our model, we might come to some conclusion, but this is going to show us like that yes, we have an estimate that, let's go look at it again, that Regis probably has less crime than Barnum, but like we're not totally certain on that because there's a lot of these green balls still too, right? And you could quickly go 2, 4, 6, 7, 35% chance that Barnum actually has the higher crime, right? That's kind of the point of these things. And I know they're like a little different and weird, but I think they're neat because it's at least a way of trying to help us understand continuous probability distributions, because we just typically don't do very good with that. Okay, so we take this data frame that we had here, and then we're going to fill according to which had the higher crime, and then we have to set some bin width. Okay, this bin width I set here is good for the plot back there. It's guaranteed basically not to work well here. This is super finicky on the aspect ratio. So I'll try 0.03. See how that goes. All right, good enough. Maybe I'll go 0.35. Sometimes you do end up with weird things like this, like they're kind of like stacked on top of each other, but whatever, good enough for now. Okay, then I'm going to say scale fill manual, and these are the two values I'm giving it, right? So that just gives me my purple color and my green color, and this tells me which has the higher crime, right? And then scale Y continuous, I'm just going to make the breaks null, which is going to remove a lot of this stuff, but it's also going to, I'm going to change my expansion to, scale Y, sorry, this way. Change my expansion to 0, which is going to shove these labels a little closer. Okay. So you can see that did that, put them closer. We also lost a bunch of our grid lines because we don't have any breaks now on the x-axis, right? Because this is just going to go from 0 to 100%, so it really doesn't matter. Then scale X continuous, I'm going to give it a name, give it some breaks, and change my expansion a little bit, not quite as much though. All right, and then I'm going to add a vertical line at 0-ish. I changed it just a little bit to make it line up for exactly where I wanted it to. Then we do some GG text stuff, right? Which is not going to look good initially because I need that theme part on there too. Okay, guides fill equals none. That's going to remove this legend here. Okay, and then finally plot.subtitle element markdown. That's going to actually make them here. And you can see now that I've added this subtitle, it's made more space up here, which means I need to go back to visiting my bin width. Try that. There, that's better. Okay. So that's the basic idea of that one. Any questions on that one or other questions on the homework as a whole?
For this one, would you show this graph to kind of communicate how confident you are with your results?
Yeah, so it's really, you know, if you think of like a normal curve, right?
Mm-hmm.
And you can think of like very regularly, you'll see people put like, well, not very regularly, but occasionally you'll see people plot like a normal curve with a vertical line here to sort of show the probability on one side versus the other. And so this is like a different way of showing that same sort of thing. And the idea is that if you cut up that interval into smaller chunks And 20 even might be too many. Like, let's try just real quick with like 10. Then you can get a better idea, yeah, of like what the chances are of not just the coin toss decision between which one is higher, but by how much higher, right? And so that's why, like, I think the election forecasting one works really well, because it's like, well, not just are you going to win, but are you going to win by 1 point or 1.5 points, etc. Right? Like, what's the chance that we're actually going to win by 2 points instead of just win, right?
Right.
Okay. Any other questions or comments? Okay. Let's move back to the slides. All right. Okay. So we're going to talk about tables now for the next little bit, and then we will take a break. Okay. And then when we come back, we'll talk about geographic data for the last lecture that we will have for this class. Okay. So as I mentioned before, I am going to mostly talk about the GT package. I just have a whole slide dedicated to this hex logo because I think it's one of the coolest hex logos I've seen. It like sort of raises the bar for what a hex logo can be, I think. So the benefits of GT is just like everything else that we do in the tidyverse, it's very pipe oriented. Okay, so that's nice because we're kind of already used to building up things with layers with like ggplot, and with our analysis work or like our data cleaning workflow, right? We go, we might have a data set and then we'll say filter and pass that to mutate and pass that to group by and pass that to summarize. And it's the same sort of idea here with building up tables. Okay, beautiful tables, relatively easy, and they render super well to HTML or PDF either way, and you don't even have to do anything. It just does it most of the time, which is pretty impressive also. Spanner heads are much easier now in Cable Extra also, but they used to be a total pain, and they're pretty easy with GT. So as I said, GT is probably my favorite for creating static tables. It actually can do a fair amount of interactive table stuff too, but we won't really talk about that. Cable Extra is also great. So nothing I say here should be taken as negative against Cable Extra. I just tend to prefer GT, and we'll talk about Cable Extra just a little bit as well, in case you haven't seen that in the past. Both are great. Whichever one you want to use is fine. Okay, so 1 minute. Please just go ahead and install GT. I would go with this first one, but you could try the second one if you want to. Okay, hopefully you were able to get that installed. And then please follow along from here. Okay, so we're going to work with 538 data again. So you should already have this one installed from past labs. So go ahead and also do library 538. And then we're going to look at this flying data set. Okay, and while you're doing that, I'll just talk a little bit. The hardest part about making tables generally is not actually going to be the creation of the table. It's going to be getting your data in the format you want for your table. Okay, so doing all of your group by summarize and then pivoting it basically to get it to be in basically the format that you want. And then from there, you create the table. Okay, so we're going to go through a pretty simple example here. Sometimes they can be much more complex, but it's a pretty realistic example too, I think, in terms of something that you might want to show. Okay, so from the flying data set, we're just going to count gender, age, and recline frequency. Okay, so recline frequency is really the thing that we're interested in, and we want to know if it differs basically by gender and age. So here, these are both both categorical variables. So we have gender, which is only 2 categories, female and male, and then we have this ordinal age category. okay, which is, basically a continuous variable that has been cut up into these categories. We have the recline frequency, and then we have the n for that. Okay. So now we're almost there where we want to make a table, except this isn't really going to work if we make a table like this because it's 53 rows, right? And so what we'll probably want to do is actually move it around a little bit. Okay, so after I count that, I decided to just go ahead and drop NAs. You could actually keep the NAs in the table too. That would be totally justifiable. In this case, I just dropped them for simplicity. Okay, but then I'm going to pivot it wider. Okay, I'm going to say the names are from age and the values are from n. So now I have a manageable table. It went from 53 rows to 10 rows, right? And so we have 5 rows for the gender, 1 for each recline frequency, 5 rows for male, 1 for each recline frequency, and then we have different columns after that for each age group. Okay, so this is a table that would make sense that you would actually show, right? And we got there fairly quickly this time, but very regularly you're going to have to kind of mess with stuff over and over and again. And like you could do things differently too, right? Like instead of having gender over here, I could have age over here, and then I could have gender up here as male, female, right? That would be another perfectly valid option. Okay, from there, all you have to do is load the GT library and then take your object. I called mine SMRY for summary, right? And then just pipe that to GT. So go ahead and try that. And a disclaimer, I'm going to show what it looks like on my slides, but I have a bunch of custom CSS in my slides to make them look the way they do. And because it's being rendered to HTML, a bunch of that CSS is getting caught up in these tables. So how they look on my slides is going to look different than how they look for you on your local. Generally, I think they actually look better on your local than they do on the slides, but they look pretty similar. Okay, so you should see something that looks close to this. Okay, anybody not seeing that? Okay. So that's our basic table, right? But now we want to start to refine this table to make it look better. So this is where we're going to start adding layers, okay? The first thing I want to do is I have gender, which is really a grouping variable. So instead of it saying female, 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 male, 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 I'm just going to say group by gender and then pass that to GT. So GT will figure out that it's a grouped data frame and it will display it differently. So if you do that, you should get something that looks like this. Okay, so notice we have female, and then we have all the categories, and then we have male and all the categories. Okay, so rather than having that thing repeat over and over again, we just have it once, which is quite a bit nicer. Okay. So this is an example where the table on the slides probably looks a little bit different than it does for you. Probably looks better for you. All right. Let's say we want to add a spanner head now. Okay, so we have this recline frequency, which is really for this variable, but you can kind of see it's broken up by male and female. But then we have all of these, which is really just an age variable. It's a single variable, but it's just split across 4 columns. Okay, so what we want to probably do is make a spanner head for those columns that says age, right? So how we do that is after GT, now we're going to pass that to tab spanner. Okay, everything in GT starts with tab underscore, pretty much everything anyway. Just like in Stringer, everything starts with str underscore. It's the same thing here. All the main arguments that you're going to supply to GT start with tab underscore something. Okay, so tab underscore spanner is going to give us a spanner head. I'm going to say the label is equal to the age range. Okay, so that's just what I want the name of my spanner head to be. And then I just pass it the columns that I want that spanner head to go to. Notice I have to use the backticks here when I'm using the different age ranges. That's because all of these columns happen to be illegal column names, right? None of those are column names that are valid in R, and so we have to use those backticks to get it to actually capture that thing. Okay. So once we do that, now you can see we have age range spanning those columns. Okay. Any questions at this point?
If those were legal column names, would you have to put like quotes, or how would you?
No, because they're illegal, that's why we use these backticks. So they are illegal, and that's why we're having to use the backticks. So if they were not illegal, we would just put the column name. Like if it was age 18, you know, if it or whatever. If it started with like not a number, then we wouldn't have to use the backticks. So I'm just clarifying that we have to use the backticks in this case because it starts with a number, basically, which is not allowed.
Okay.
If we have two categories, then we just like add the name on the label.
So you mean you have two spanner heads?
Yes.
Then you would just pass this to another layer where you would add another tab spanner.
Spanner. Oh, okay, got it. Thanks.
Other questions? Okay, so it should look like this now. And now we're going to change the column names. Okay, so we have this one that's called recline_frequency right now. And I don't really like that name. So instead, I'm just going to say calls label. This one that's called recline frequency is going to equal recline. Okay, and I only have one column that I'm relabeling here, but this works just like the rename function in dplyr. Okay, so it, except I guess it's backwards from the way it is in dplyr. So what it was is equal to what you want it to be. Okay, and now we're looking like this. So I would argue already we have a pretty good looking table here. There's still some things I would want to do to it, but it's a pretty good looking table for creating that pretty quickly, right? We also, I don't think you have to do this. I could be wrong, but this is, I think, one of the things that's introduced by my CSS. So I don't like how these are all centered. I'd rather them be left aligned. So I can do that by using this calls align. So I guess they're not all tab because this is something that's affecting the columns rather than the table. So that's probably what it is. There's probably a row underscore also. So we're going to left align the columns for recline frequency. And notice I have this vars thing I'm wrapping this in. This is because we could potentially have multiple variables that we want to pass it to. And so we could say left vars, recline frequency, age, whatever, however many other ones we have. We could just pass them with commas inside of here, inside of this vars thing. Okay, and that shoves them all over. Really, ideally, I'd probably want these actually indented just a little bit, but I didn't do that. I'm sure there is a way to do that.
Hi, Daniel. So if you want to change the values in recline, like never, once in a while, those to something else, do we add that on calls underscore label or?
No, because that is just for the column name.
Okay.
So I'm not sure what the function is that would do that off the top of my head. However, I do know that one thing you could do always is you could just recode those in your actual data before you create the table, and it would work fine.
Oh, okay, yeah.
I'm sure there's probably a way to do it in GT also. I just don't know how to do it off the top of my head. Okay, then we can give it a title. So here I'm saying tab header, title is airline passengers, and the subtitle is leg spaces limited. What do you do? There you go. Okay. So that's basically it. I have a few other little more fancy things that I'll show you. What I kind of wanted to do here is at this point, these are all numbers, raw numbers, right? Which is fine. But maybe instead of showing the numbers, I want to actually show the percents. Okay, the percentage of people. So notice in my summary here, I'm going to mutate across these columns and I'm going to say whatever that value is, just divide it by 100. Okay, and then I'm going to group by gender, create my table just like before. But then here for these columns, I'm going to say format percent. So these variables, I want them to be formatted as a percent with 0 decimals. Okay, and that gives me this. Okay, which I think is pretty nice, because what we have up here is actually a proportion, right? So these are like 0.19. And then when we pass them to format percent, it just formats it as 19%. Okay. You can add a source note if you want. Notice there's this MD function, which I think is pretty nice. So you can say data from 538 and put like markdown syntax in there. And it will end up rendering as a link like that. Okay. Just a few last things. These are a little more advanced, but kind of fun. One thing you can do too is say data color. Okay. And then say for these variables, I want to apply some palette to those cells. Okay. So if it's a higher value, it will be one color. If it's a lower value, it will be a different color. So I'm saying the color is equal to call numeric from the scales package that has a palette where the lowest value is white and the upper value is this red-ish color. Okay, domain is null. That basically means it'll figure it out, I think. Okay, and then it looks like this. One of the things that I think is pretty darn impressive about that little bit of code is, I think this is kind of nice. You have basically then a heat map with your table, right, together. But the other thing that I think is pretty impressive is once the color gets above a certain threshold, it automatically changes the text color, right? So there are like visibility things embedded in this. And so it knows once it gets like past a certain threshold, it needs to change the text color to white so that you can still see it, right? So I think that's pretty impressive. And if you want to impress some people, you know, having a table with a heat map on it is pretty nice, I think. On that domain, we could also say, you know, like 0, 1 or something like that. And that would tell, because the proportions are 0 to 1, or maybe you have to do 0 to 100. I think 0 or 1, but so this one, like the max value is like 40%, right? So that's going to be the top of the scale here. Whereas, and like the minimum value is like 10%. So that's going to be the bottom of the scale. But if we wanted to, we could make the bottom of the scale 0 and the top of the scale 100%. You wouldn't get as much variation in here, of course, but it might be more honest because some of these like 11, 15%, they look probably lower than they actually really are. Okay, so what else? There's a lot more on the website. So this is the website. There's a bunch of stuff on here. One of the things that I think is good are these, there's this case study for GT cars where it kind of just takes you through an example with a bunch of different cars, and it walks you through just like I did, but for a much bigger table. Okay, so group by city, and then it keeps going and going and going and going and going. Okay, and some of they show you a whole bunch of different options, and like the text size is bigger here than it is over here, right? There's a bunch of like built-in things like that that I think are pretty nice. Thomas Mock, some of you may know of him. He was the guy that really got Tidy Tuesday going in the first place. He does a lot of different stuff with tables. So I just went full screen, but I need to come off again. So he has multiple tutorials on building nice tables specifically with GT. So this one's for like QBR. So this is like his first table, but then you get to the bottom and he talks about embedding like these spark lines and stuff, which we'll talk about a little bit too. And then you get all the way to the bottom, and here's like all the quarterbacks, right? And you have like little pictures of the quarterbacks embedded in there and stuff like that. Okay. So there's 3 different links to tables from his blog there. Okay, so that's GT. Questions on that before we move forward? I know that's quick. It's just a very quick intro. tables aren't like my favorite thing, so I tend to not spend a ton of time on them. But I do think they're very important, and there's a lot of really new, neat things that are coming out from them. So, any questions? Okay.
So for to add color, the domain thing kind of like sets like the arguments, right?
Yeah, it sets the boundaries of this.
Okay.
Like this is your palette, this is like your low value, and this is your high value. And so when you say domain equals null, it's just going to figure out it's going to use the lowest and the highest value from your data set.
Okay.
But you can specify it on your own. So like 0 and 1 in this case, or 0 and 100 or whatever.
Okay. Is it possible to add like arguments, like if it's this and I don't know, if you like have two conditions?
I'm not sure. So this is, I think so. Do you mean like you want it to be more categorical? So like it's
Right.
highlighted if it's a specific value. Yeah, I'm almost positive that is possible. You can see here we're using call numeric, right? I'm pretty sure there's a call, qualitative or call discrete or something like that. And then you'd probably just have to specify either values or thresholds or something like that.
Got it.
But I don't know what it is off the top of my head, unfortunately. Other questions? Okay. A few other table options. So I want to talk about Cable Extra for just a second. So Cable Extra is a very nice package. There's really good documentation on it. It's been around for quite a bit longer than GT, so it's more established. If you're using it in R Markdown, you probably want to make sure you have results equals as is in your chunk options. But here's a just quick example, right? I have to load knitter and then Cable Extra, and then I have this thing I'm calling DT, and I'm just taking the first 5 rows of empty cars and the first 6 columns. Okay, and then I call cable on DT, and then cable styling, and I say striped, and then I can pass that to column spec and say columns 5 through 7 are going to be bold. Okay, so 5, 6, 7, they're bold. Okay. You can also do similar sort of things where you can do row specs. So here's the column spec making 5, 6, 7 all bold. For a row spec, I'm saying for rows 2 and 4, they're going to be bold, but we're also going to make the color basically a white color, and then the background this blue color. Okay, so that's pretty neat too, I think. And then you can also do the grouping thing. So this is where I think GT is quite a bit nicer than Cable Extra if you want to do something like this. This is called pack rows, right? And so you'd say group 1 goes from row 1 to row 3, and then you can change the color by basically passing some CSS in through a string. And then group 2 is going to be rows 4 and 5. Okay, so group 1 goes 1, 2, 3. Group 2 goes 4, 5, right? And so it's a bit more manual, but you do have more control over it as well. There's lots of different more options with Cable Extra as well. If you want to look at the documentation, they have separate documentation for HTML output and PDF output. They're very detailed. The guy who created it is very nice and he's very responsive, so you'll be able to get help with it. It's a great package, and it has lots of options. Okay, and it works with PDF and HTML. So everything I've talked about though pretty much works great with HTML and PDF, but I haven't mentioned anything about Microsoft Word yet, and we all probably work with Microsoft Word more than we'd actually like to because it's academia, right? Like that's what everybody uses. So if you're going to work in Word, there is a package called Flex Table. I'm not going to really spend any time on it, but I have it linked so you can go to the documentation there if you'd like. I haven't used it a ton. I've used it a little bit, but it does tend to render to Word more easily than some of the other ones. And there's a ton of other options. So there's one called Huxtable I've used in the past. It's pretty nice. Formatable. DT, it used, instead of GT, there's DT. DT used to actually be my favorite if I was going to do something with Shiny, but now I always use Reactable, which we'll talk about here in just a minute. And then our hands-on table. So these are all links, so you can look at those more if you want. I don't want to spend the time on them today, but there are lots of different options. As I said before, I would recommend probably just starting with GT. If that's not working, you'd probably look at Cable Extra. If that's not working, then I'd go to one of these other ones. That's my approach anyway. There's also other sort of specialized packages for tables. So for modeling, this model summary is built on top of GT. It's a really amazing package. So you fit a model and then you basically just pass it to model summary and it will, let's go look at this one real quick. So it will basically just take your model object and create these beautiful tables out of them. Okay, so here's an example. Fit a model, then you call model summary on mod, and then you can tell the output you want. It works really well. Okay, so that one is really nice if you're doing a lot of modeling and stuff. That would be the first one I would go to of these. The other two are kind of older. And then for descriptives, GT summary is super nice too. So GT summary, you can just pass it a, let me go here actually instead. You can just pass it a data set, and then it will build you a summary table from your data set. Okay. And so you can, again, do piping sort of stuff, add in, add P, modify header, whatever, regression models. Okay, so it does a lot of really cool stuff too. So, and both, this one's also built off of GT. Okay, and then the last one I wanted to talk about, and then we'll have a break, okay, is Reactable. Reactable is my favorite for interactive tables. It's a really amazing package, I think. You can create tables like this, and it's you know, this one's probably fairly difficult, but like this is a super amazing modern table, I think. And you can do it with Reactable. So what I would like you to do is, again, please go ahead and do install.packages Reactable, and then we'll walk through this together real quick. Okay, so once you have that loaded, let's go ahead and load the Plumber Penguins dataset, load Reactable, and then all you're going to do is just say Reactable Penguins, okay? And then it's going to create a table for you that is interactive. So you can see down here, I have this little thing. I can click next, next, next. I can also come up here and click on them and sort them by their body mass or their flipper length or whatever, right? Or their island, which would just be in alphabetical order. So just immediately, I have a pretty amazing little interactive table, right? But there's a lot more that we could do from there. So from penguins, you can pass that to Reactable, and then say the columns is going to be a list, okay? And it's a list because you're going to pass different arguments for each column. So you can only pass one if you want, or you can pass a bunch of them. But for the bill depth or bill length, I'm going to say here's the column definition. The name is going to be bill length millimeters and bill depth millimeters rather than what they were before with the underscores. Okay, and that looks like that. But you can also do a function. So I have default call def instead, and then I say call def, the header is equal to a function that takes an argument x, and we're just going to go string to title, and we're going to substitute all the underscores for spaces in x. Okay, and that mostly works, but you can see we've got bill length millimeters, right? That M should be capitalized there too, but it's not. But otherwise it works. Okay. The other thing we can do, and you should be able to do this with your table, is just add filterable equals true. and that'll add these little filters up here, which is pretty neat because now I can, let's say I want to look at Gentoo penguins. I can just type a G there, and it's going to filter the data set to only Gentoo penguins, right? Or maybe I want just female, right? Pretty neat. And it's only one argument. Okay, you can also change the pagination. So you just say the default page size. By default, it is 10, I believe. Yes. And you can change that to 3 or whatever you want to change it to. There's also this page jump thing. So instead of pagination type equals whatever it is, whatever this is, you can say jump. And so I can change the page like this. I can still change the page like this, but I can also now enter 115 and just go right to the end. Whoa. Except I accidentally jumped around in my slides. I went way back there. Okay, but that should work for you if you're not working in slides. There, it did go there. It just also made my slides jump. There's also this grouping thing. Occasionally, this can be really useful, but sometimes it, like if you just look at it like this, it doesn't look very useful, right? But so what I do is just say group by, and then you say what you want to group it by, species and island. So now I can click here, and here's within Adelie, I have Torgenson, Bisco, and Dream Island, right? And then I get all the data for those. And I should be able to scroll down, but I can't because it goes off of my screen. Okay, so that's like kind of weird, but so Gentoo only has Bisco, right? So that's interesting. Chinstrap only has Dream. So that's kind of interesting too. So you can see things about the data maybe that way that you can't otherwise. But what's also nice is if you do this, you can also add aggregates. Okay, so I'm grouping by species and island, but then for my bill length millimeters, I'm going to aggregate by computing the mean and format it to so it has 2 digits. Okay, and what's cool about this is right now, bill length is 38.81. That's the mean for Adelie, right? But when I click down like this, notice I still get 38.81, which is the overall mean, but I now also get means for each island. Okay, so I get different means reported for each island, and then I can click that and I get the rest of my data. Okay, so these are the individual level observations still. Okay. Sparklines, this is fairly complicated. So I'm not really going to go through this code all that quickly, or I mean, all that closely. I will go through it quickly. You can see that the code is relatively complicated, but it's nice because you can create these little sparklines like this. And these are actually little interactive plots that I have a hard time getting. But yeah, see that? When I hover, it's going to show me some stuff. These should give me a hover too, but I have a hard time doing it on the slides for some reason. Let me see if I come here. Yeah, I don't know why I can't do it there. This one does though. Anyway, kind of neat. And there's lots more, of course. So the idea of today is give you like a brief introduction to them so you can check them out more. This reactable formatter one, I mentioned this before. It's a pretty amazing package. It just builds on top of reactable and makes some of the things a little easier for you to do. So like this is a tutorial on creating bars, and it's super nice, right? Like here's the data that I create, and then you're going to say reactable for data. And then for the default call def, I'm going to say the default call def is data bars. And then you get bars that look like this, right? And this time I'm going to say I want the text position outside instead of inside. And now they're going to be inside base, right? And so there's a whole bunch of different things you can do there. These are kind of neat. There's some down here that I thought were really cool when I was looking at them earlier. Yeah, I like these, like the rounded ones, kind of neat. All right, and there's a bunch of different stuff. And the thing is, it's cool about this too, is you can still click on them and those bars still change. All right.
I have a question about the sparkline stuff. So is it possible to have like a histogram of your data as well as the actual summaries?
Yep.
Okay. So you can kind of mix and match it.
Yep.
Because a lot of the examples are really good like just images or just numbers?
Yeah, so those spark lines are little interactive plots like actually in the cell. And so you can have another column that just has the aggregate also. Okay, so that's it for that. Let's go ahead and take a break. We'll be back. It's like 2:40. We'll start like 2:45-ish, somewhere around there. Okay. All right. We ready? Here we go. So, I already sort of had this disclaimer, but there's a ton, like geographic data is a ginormous topic. We have, roughly an hour to cover it. So I'm not going to be able to do a lot of this very much justice. But I'll try to get as far as we can. All right. It's very much an intro. It's really, we already went over these learning objectives, but it really is partially about the content and partially about exposure. Okay. I always struggle with these classes with knowing when to go broad and sort of show what's out there and allow you to kind of go out and explore more on your own versus saying, okay, this is a topic we're really going to dive deep on and really, explore in detail. So this is very much more of a high level view of geographic mapping. And we'll dive a little bit deep on a few of them. So there's lots of resources to learn more. Geocomputation with R is a great one. This is an open source book. I think there's actually a second edition. Yeah, second edition is under construction. So you can look at that too. So this is the original one, right? And then let's see. Yeah, I guess I don't know how under construction it actually is, but they're working on a second edition now, so that's interesting and fun. For some reason, these never end up showing up, but this is a link to, is supposed to be a link to this. Oh no, not that. I had so many things open. So RStudio, every year they have their conference, and prior to the pandemic anyway, they always had these training days before, which were 2 full days of training on some R topic by some of the best people out there. And so what's really nice about that is you can go, this is the 2020 version, right? You can go to their repositories and they have all of their materials for these posted here. Okay, so there's just a ton of really good stuff in these. One of them, which I did not attend, but is on geospatial stuff. Okay, so I'll put this link in the chat if you want to look at it, and those of you not on Zoom, I'll try to get it to you a different way. Okay, maybe I'll put it on Canvas afterwards or something. But if you go to materials in here, you can see all the slides are there, right, as PDFs, and there's exercises without some package. I don't know. Yeah, so here's a bunch of stuff. I don't know if the actual exercises are in here. Yeah, there's the exercises. Okay, so here's a bunch of exercises that you can go through as well. That would be good too. Okay. So this is great for geospatial stuff, but just this RStudio Conf thing generally is a great way to learn more about some specific topic. Okay, to see if it's there. All right, starting out though, let's talk about vector versus raster data. I think this is from Zev Ross, the guy who did the geospatial training, but I think this little graphic is just such a nice way to show the difference between vector and raster. This is vector, right? It's a bunch of polygons and points and things like that. This is raster, right? So it's dividing the thing up into a grid and then filling it in based on some color. And so you can see with raster, you're going to lose some detail because you're pixelating it. right? So vector data are points, lines, and polygons. And you can very easily often include non-spatial things attached to these. So you can have some polygon, and then you can say within these polygons, how many people live in that polygon? You know, how many, I don't know, plants are there? How many trees are there? Whatever, anything that you want to say, you can attach to vector data pretty easily. They can come in shape files usually, which are .shp. GeoJSON is another one. I haven't used that one much, but I know it is out there. And very frequently, you can also just get shape files directly through R from different R packages. They will either just download the data for you, or if they're small enough, it might just ship with the actual package itself. Okay. This is mostly what we're going to talk about for the rest of today is vector data. So in my experience anyway, with sort of social science research, vector data tends to be the most useful. There are uses for raster data for sure. Especially when you're talking about like demography stuff and looking at spatial density of demographic groups and movement of groups and things like that. But I don't have as much experience there either, which is part of why I'm preferencing vector data. Okay, so for raster data, rather than having some polygon or lines, we're just going to divide the space up into a grid, and then we're going to assign each square a value. Okay. Common formats for this are like satellite data and also just images, right? You could have literally just an image of a space, and that could end up becoming spatial data. So as I said, it can occasionally be helpful in social science data. This is an example of actually mixing the two. So this is has vector data underneath it, and then it has raster data overlaid on top of it. So this almost always, that I have seen anyway, in social science research, if you're using raster data, it's a mix of the two. Usually raster data being plotted on top of the vector data. Okay, so this was when we had that ridiculously cold spell. I can't remember when, a little while ago. And I think this is an unbelievable map. Like, I think this is so well done, because the raster data are from like, you know, down to a very small level. You can actually see the pixels though, right? But it's still a very small level. And then they essentially annotated it with these lines. And then they omitted, oh, well, they have a legend, but they also have like these annotations to give you an idea with just looking at it without the legend, what the temperature was. And you can see even here, it's above 32 degrees. It's like that. So it was really cold, right? This was when people in Texas were losing power and burning mattresses and stuff to stay warm. So this is a really good example of mixing the two, I think. In terms of our stuff, more specifically, there's this hashtag #RSpatial, right? So if you're really into spatial stuff, I always recommend Twitter. I think it's a really good community for our stuff generally. And so you have the hashtag #RStats that is the most commonly used, but then you also have hashtag #RSpatial. If you're into Shiny, there's also hashtag #RShiny, etc. Okay, the main packages in the #RSpatial ecosystem are SF, which stands for simple features, and we'll talk about that quite a bit today. Okay, there's also raster, which we won't talk about really at all. And then there's ggplot, which obviously we know, and tmap, which is sort of like an alternative to ggplot. And it works pretty differently, but I mean, it works the same sort of conceptually, but it builds maps really differently. And it can very often be much, much faster than ggplot. So that's one reason to preference it, possibly. It's also, it can make unbelievable maps. Like, it's really, really powerful. And ggplot can also, but it's definitely worth exploring, I think, if you want to do a lot of spatial stuff. And then finally, we'll talk just a little bit at the end about this one called map view. When I last put these slides together, it was a newer package. It's not really that new anymore, but it is nice for producing very simple interactive maps. Okay, so if you want to map you just want to make it instantly interactive and be pretty simple. Map view is going to be really nice because it will do it for you, but it'll also make sure you have the right projections and all that complicated stuff that we don't want to think about too much. So my goal in the next hour-ish is to take you through most of these, minus raster, but we will talk about raster data, at least at a small level, okay? Geographic data also has a lot of challenges to go with it. So this is one of those, I want you to be aware of it, but we're probably not going to really talk about it too terribly much. So coordinate reference systems are one part, okay? SF is going to be nice for that because most of the time it's going to set the coordinate reference system for you, depending on your longitude and latitude. It's going to sort of figure it out for you. And then there's also list columns, which we won't really need to deal with too much. There's also this stickiness with SF objects, which is, so the list column in an SF object is the geometry, okay? And that makes them so much easier to work with because you can have a row that represents, say, a county, and then you can have the number of people that are in that county, and et cetera, et cetera, et cetera. And then you have a cell, right, at the end of that row that is all of the geometry for that county. So it's the entire polygon for that county, okay? So that is super nice in terms of working with it, but it has some difficulties. I think actually the biggest difficulty is the stickiness part of it, and it makes sense why it is that way. But basically, if you say, for example, had an SF data frame and it's at the county level, and you said select county and N for the number of people in the county, it would return to you the county name, the number of people, and the geometry. It would return the geometry always, right? The geometry is like part of that data frame, and you cannot drop it unless you explicitly say, I want to drop it. So that can end up making it more difficult sometimes to work with some of the tidyverse tools. They won't work as easily sometimes. So generally, I think it's a good thing, but it can make things a little bit more difficult. Different geometry types can be challenging sometimes. So when you have lines versus points versus polygons versus multi-polygons, vector versus raster data, that's not that big of a deal usually. And then sort of this import output of data. Generally with vector data, it's going to be pretty easy. Raster data, not so much. Raster data can very often be very, very large, and they're usually stored in these bricks of data. Okay, so you usually have, for example, if you have something like remote sensing, like satellite sensing data, then it's usually going to be an image at one point, an image at a second point, at a third point, at a fourth point. And so you have like this stacking up of them over time. So that can be very big and very difficult to work with sometimes. All right, getting spatial data. We're going to only talk about a few ways to do this, but there are lots of other ways. I would like you to follow along on some parts of this if possible. I sent out an announcement earlier about possibly getting an API key for the census. Hopefully you were able to do that. I will show you how to get data from the census later if you did that. If not, you could go and try to request it now. You probably won't have time though, because they have to email it to you. And so I think it usually takes like 24 hours or something like that. So we'll cover a couple of different ways. It's pretty purposefully United States centric because that is what I know the best. So I apologize for that, but that's just kind of what it is. Generally, reading shapefiles is not going to be super difficult, but like I said, manipulating raster data can be tough. There are also tons of different organizations that publish spatial data, because spatial data is kind of different, for at least compared to what I'm used to, where the data that I get from like schools, right, I can't share that with anybody. Spatial data is like, it's like the shape of a continent or whatever. Like it's not something that's like super protected. So there's lots of different organizations that share this stuff. And if you can find a shape file of whatever it is you're trying to plot, then you're in good shape. That was not intentional. good shape. Okay. Working with spatial data. So you do have two basic options. There used to be, the standard used to be SP, okay? And SP was spatial polygons data frame or spatial lines data frame or whatever, right? And they were data frames that had been sort of transformed to handle spatial data, but they really are, like if you're used to working with a standard data frame in R, these are much more difficult to work with, okay? They don't print the same, they don't handle the same. And so this still exists and you can still use those for sure, and you'll see them out there, but I'm not really going to talk about them today. We will be working with SF data frames. In my mind, SF has pretty much superseded SP, okay? There might be other people that disagree with that. You know, geographic data is something that like I do, but it's not like I would not consider myself an expert in it. So there might be some areas or some things that you might prefer data from like in the SP format, but I almost always work with it in the SF format, okay? So if you happen to have data that's in the SP format, so you just get it from an R package or whatever, it's already in that SP format. From the SF package, you can just do SF ST as SF. For some reason, I don't totally get this. I should just look it up. I'm sure I can figure it out somewhere. But the SF package, almost all of them start with ST, okay, ST underscore. And so we're just saying, oops, wrong thing. We're just saying as SF. So we're taking this SP object, like spatial polygons, data frame, spatial lines, data frame, spatial, whatever, special points, data frame. And we're just changing it to an SF object. All right. One of the packages that I think is kind of neat for getting data is this one called Tigris. Okay, this comes from the census. These are the geography that the census uses for a bunch of different stuff. And you can get all sorts of different things from this. Okay, so if you want to go ahead and install Tigris, if you don't already have it installed, then let's go ahead and load Tigris and load SF. However, I also want to point out this line, which is very important, that says options Tigris underscore class equals SF. Okay, that means when it imports the data for you, which we're going to do here in just a second, it will import it as an SF object instead of an SP object, which is the default. Okay. Okay. I'm going to switch my share so you can see this. Okay. This is the help documentation for roads in Tigris. Okay. All we do is we say roads, we say the state, the county, and the year if we want to, optionally, and it will return the geography for the roads in that state and optionally county. Okay. But what I really wanted to show you is if you go to the index of this, you will see all sorts of other things that you can do. Area water, coastline, right? Counties, divisions, county subdivisions, FIPS codes, geojoin, landmarks, like military, nation, native areas, New England, like all sorts of different stuff, right? And so this is voting districts, like that's kind of a cool one too, right? There used to be school districts in here too. Yeah, school districts, but that's actually not the best. You can try it, but at least it used to be there was a lot of missing data in the school districts. So you can try it, but like in Oregon, there would be a bunch of missing data. Okay, but the good news is there's a bunch of stuff in here, right? And this all comes from the census. Okay, so now what we're gonna do is we're just gonna look at the roads for Lane County to start. Okay, so I'm gonna say roads for Oregon, and the county is equal to Lane. Okay, so then roads Lane Co is gonna return, it's gonna take a second to do that. All right, and when you load SF, it's gonna probably tell you to give it an option to cache. You should probably run that code also. Okay, that way you don't have to keep downloading it if you want to use it again. All right, but this is an SF data frame. So it says simple features collection, right? And the geometry is line string. So we have the full name of the county, basically, right? And then no, this must be of the road, is what it is. And then we have the line string. So it's just a geometry of a string, basically, as it moves around. Okay. If I wanted to write this file to disk now, right? So I wanted to, let's say I've downloaded it and I know I'm going to use it a bunch of times. So I'm going to write it out so I don't have to keep downloading it each time. I can do it pretty easily with the SF library. I just say, and you don't have to follow along on this part. We'll plot it here just in a second. But you can just say write SF, give it your roads lane co thing, and then the same as like if you're doing write CSV, right? You just give it a path to where you want to save it. Notice though that I'm saving it as .shp, right? The shape file. Then if I want to read it in later, I just say read SF and I just give it to the path to that. And we get the SF data frame back, just like we had it before. Okay, so that is hopefully pretty straightforward. It's not too much different than using a CSV or anything else. Okay, now we can actually plot this just like this. We're going to go ggplot roads lanco plus geom sf. Okay, and then and that's all you have to do really. You can also specify a color or whatever else. All right. And if you're trying to do this locally, which I would suggest you do because it's kind of fun to get to try this, you'll probably see that it will take a minute to render this because that's a lot of lines that it's drawing. And so it can't happen immediately, right? It takes a second. All right, let's say now instead of just roads, we wanted to also add some water, okay? So I'm gonna say, give me the lakes and give me the streams. Okay, streams, it's really not streams, it's linear water. So there's a bunch of drainages and whatever, like it's a bunch of water, right? So I'm saying linear water for Oregon in Lane County and area water for Oregon in Lane County. Then when I'm going to create my plot here, notice I have ggplot here, but I'm just keeping that completely empty, because I'm going to specify a different data set on every single layer. Okay, so for the first layer, I have geom sf just repeated 3 times. First layer, I'm putting the lakes. Second layer, I'm putting the streams. And finally, I'm putting the roads over the top of that. And then I just change the color for each of them. So that these two are the same, but then I have gray for that one. Okay. So these are all from the Tigris package. And when you do that, you should see something that looks something like that. Okay. As I said, that's a lot of water, right? It's not just like rivers and streams, it's every drainage, basically. Okay, there is also a package called OSM data, which stands for OpenStreetMap data. It has a lot of really cool functionality too. Some of it is a little redundant with Tigris, although it's at a deeper detail than Tigris, I think. So one of the functions it has that is really nice is this one called getBB, get boundary box. All right, and you can just specify a city and it will specify a boundary box for that city rather than having to look at the entire county, right? So here I'm saying OSM data, getBB, get boundary box for Eugene, and it gives me the min and the max for the x-axis and the min and the max for the y-axis, right? The latitude and longitude. So now in this one, I just add another layer and I'm going to say chord SF, where the x lim is equal to the first row of my boundary box. Okay, those two things. And the y lim are equal to the second row of my boundary box. Okay, so notice I'm saying the first row, all columns, second row, all columns. Okay, and that basically just zooms this in on just Eugene. All right. So let's very quickly, we can replicate this exact same thing with just fully OSM data. the way we would do this is we're going to go OSM data. I loaded the color space package as well. We have our boundary box, and then we use the pipe here. So we go boundary box, that passes to OPQ, which stands for overpass query. Okay, so we're querying an API to give us the thing we want. And then we say add OSM feature highway. Okay, so this is just adding the highways. And then this last line, OSM data underscore SF, is changing it from an SP object to an SF object. Okay, so this is the roads. And then for water, I can do the same thing, add OSM feature water, pass that to OSM data SF. Okay, and then we can plot this. This is a little bit interesting because each of these things, this roads and this water, they have multiple different geographies or geometries. Okay, so this first one, I'm taking the multi-polygons from water and I'm making it one color. The outline of it, I'm making a little bit darker. Okay, and then so this is the multi-polygon, and then this is just the polygons. And I'm not totally sure what the difference are between those two. I can't really remember, but you could play with this code exactly and figure it out. And then this one for lines, this is going to be more like rivers and things, right? Because it's just a line rather than a polygon. Okay, so we're going to make that a different color too. And then we're going to go OSM lines for the roads. Okay, and then make that gray 40 instead of this bluish color. Set our boundary box, and then I added a caption that says Eugene, Oregon as well. And we get something that looks like that. This is actually, I think, pretty amazing that we can create that with R that quickly. If you go and look like on Etsy, you can find stuff that looks basically exactly like this that people are selling, like prints of, you know? So you could start your own little business with R on Etsy by just drawing maps for people if you wanted to. Anyway, I think it's pretty neat. All right, census data. Can we just so I know that it's worth doing this right now? If you are on Zoom, let me pull down. If you are on Zoom, can you please give me like a thumbs up if you got an API key? Okay, great. All right, we got enough people. I don't even have to ask the people here because we got enough. Okay, so what we're gonna do is I'm gonna switch my share to here. Actually, I'll keep them both going. All right, so this is what I was working on before. But so what we're gonna do now is you should all have the use this library installed. If not, I think it's installed with tidyverse and everything. But if not, you can just do, install.packages, packages, use this. Okay. But I would just try before you do that to just run this next line of code. You'll go use this and you should get something that looks like that. If you have that, if that's popping up, then you have used this installed. Okay. And then just type edit and you'll see this one edit underscore R underscore environ. Okay, that's the one you want to click. And then you're just going to run that line of code. Okay, that's going to open up a file for you where you will probably have this one. I think it's that one. But you probably won't have anything else. Okay, or you might have one or two other things. I have a lot of things. But what you're going to do then is get your census. You're going to type in census API key, just like that. Census underscore API underscore key is equal to, and then you're going to paste your key in there. Okay, so this is my key, and yours will obviously be different. But you want to paste your key in there to your R environment. Okay, if we look down here, it says modify your R environment and then restart R for changes to take effect. So after you do that, after you paste that in, you're going to have to go session restart R, and then it should work from there. Okay, the next slides for you. Yeah, you do have to save it. So after you put census API key equals, paste it in as a string, save it, and then do session restart R. Okay, so the code again is use this : edit _ R _ environ, and that should open up this file. That's all that code is for, but it's really nice because that code is kind of stored all over the place. Or it's not really, but it can be hard to open because it's a hidden file. Okay, we'll go back to the slides for a second. So this is just recapping what I just said. You can also, instead of doing this, if you can't get that to work for whatever reason, at the top of your script, for every single time you do this, you could say census API key and then just paste your key in there as a string. The reason you would not want to do that is you don't want to ever post your key to a GitHub repo. Okay, any API key you have, you shouldn't post it to a GitHub repo because other people could then access that key, assuming it's open, a public repo, right? And then they could start using your key for nefarious things that you don't want to do. So that's why we try to avoid this, and instead we put it in our .r environ, and then the package that we'll be using here in just a second can access your key from your .r environ, and everybody has their own, and it works beautifully. Okay, so again, census API key equals whatever your key is. Okay, now we're going to use a package called tidy census. Okay, so you're going to have to probably do install.packages tidy census, and then we're going to load tidy census, and then we'll have this package or this function called get ACS. Okay, which I'll talk about in a second, but I'll wait for you to install it first. Okay, I'm going to get started on this. If it's still installing, that's okay. But one of the things we can do is first we can use this function called load variables. Okay, and so I'm going to just specify a year and the survey that I want to get the variables from. So if we just look at the help documentation for this, we can see that it says it's going to load variables from a decennial census of American communities or American Community Survey datasets to search in R. Okay, so you say the year in the dataset, and so the dataset is one of these ones. So you can get data from any of these datasets that it has here. So I'm going to go with the ACS 5, all right, and the American Community Survey 5-year survey. So I do load variables, and I save that in this object V. Okay, so then I can go view V, and it looks like this. Okay, so here is the name of the variable. Okay, and this is some label and then concept. So we have this variable is going to be the total sex by age. Okay, and so this is going to be the total for sex. This is just going to be the total, actually. This is going to be the total for males. This is going to be the total for males under 5 years old, et cetera, et cetera. Okay, you can come clear down here, sex by age, by race, it looks like. And I mean, there are tons of them, right? So there's detailed occupation by median earnings. So there are tons and tons of variables in here. Household type, there's things on economics, there's things on demographics, all sorts of stuff. Okay, so these are the variables that are available to you. And the way that we get those is we just say get ACS, and then we specify the geography that we want. In this case, I'm specifying that I want census tracts. Okay, a census tract is like kind of a made up boundary in terms, I mean, all boundaries are kind of made up, but it's a census boundary, right? It's not like a legal boundary. And what it is basically they're made to help balance population density. So they're supposed to center on about 2,000 people in a census tract, right? And then they can range from anywhere to like 200 to like 8,000, but there's somewhere in that, because sometimes it's too hard if there's a lot of people in an area or whatever, or not very many people. So that's what the census tract is. We could have done like counties or states or whatever, but I just went ahead and did census tracts. I said for the state of Oregon, and then for our variables, notice I am specifying two variables here. This one is the median income, okay? And this one is the educational attainment, okay? The values of these things are weird because they're kind of scaled, so they're not like on, like educational attainment is like 4,000 or something, 4,023. It's like, well, what does that mean? It's because they've transformed those into like some continuous variable. Then you specify the year, and then for us, for our purposes, we're always trying to plot these. So we're going to say geometry equals true. And that way it will return not just the census values, but also the geometry associated with them. Okay, by default, this is false. So this is a pretty important one for what we're going to do. Okay. Earlier today, I tried this and the API was down. So I hope that's not the case still. Let's see if this works. Yes, it worked. Okay, so now I have census vals, which looks like this. Okay, so you can see the geo ID, and we have these census tracts. We have this census tract is in Jefferson County. So it's census tract 9603.02 in Jefferson County, Oregon. And we have the median income and the educational attainment. So that's why there's two rows for that census tract, right? And then over here, we have the estimate. And then we have MOE, which stands for the margin of error. Okay. And then we have the geometry over here for that census tract. Okay. So that is, I think, a pretty powerful way to get a boatload of data on all sorts of stuff. Okay. So we've already looked at that. For me, for whatever reason, I've never had this issue until this time going through this. But if let's see if it's still there. If I look at the tail of census vals, yes, I was getting these empty polygons, right? So here's for Douglas County, census tract 9900, I'm getting an empty polygon. So it's like the geometry is not actually coming in, even though it's supposed to. But like, when I look at the map, I can't see anywhere where it looks like it's missing. So the problem is, though, if you try to plot this with empty polygons, then it will fail. Okay. So what I had to do is remove these rows like this. Okay. So census vals, that's the thing that we called it, right? And I'm just going to use the brackets. Oh, shoot. This is going off the screen. So the brackets, and then you go not st underscore is underscore empty, give it the geometry, and then you go comma, comma, drop equals false. And the reason is you're saying give me these rows for all columns, and then this is an additional argument, drop equals false. So that's kind of complicated and weird, and it's not usually the case, but if you want, you can just copy that code right out of the slides. And then from there, it should hopefully work. Okay, so I'm going to start by plotting this, and I'm loading the color space library, and I'm going to use this blue red 3 palette, but I've reversed it. Okay, and so this is a diverging color palette, so it's going to center at white, and then as it goes more one direction, it will be blue. As it goes more the other direction, it will be red. Okay, so I have census vals. I'm going to say geomsf fill equals estimate and color equals estimate. Okay, so I'm going to fill, and the outline of it and the fill of it are going to be the same thing. I'm going to facet wrap by my variable, which was educational attainment and median income, right? And then I'm going to say guides color equals none to just drop the legend. That looks like this, which is probably not really what I want, right? This is not very helpful for me. If you try to do this, which you can, you're welcome to, of course, you'll get a similar looking thing. It will take a little while to render. Almost all of the SF stuff in maps and things It'll take a little bit of time because it's just a lot to draw. Okay. But this isn't really what I want, I don't think, because these estimates are like on crazy different scales, it looks like. Like this is all white. That's not really helping me very much. This is all blue. That's not really helping me very much. So I'm going to try again. This time, I'm going to just create the income plot. Okay, so I'm creating an object here called income where I'm just filtering my census files where the variable equals med income, right? The median income. Then I'm going to go ggplot, geomsf, facet wrap by variable. I should actually get rid of that part. Guides color equals none, and then scale fill continuous. Notice on this, I'm also saying make the middle of this, by default, the middle of this diverging scale is going to be 0. That doesn't make sense in my case because 0, we're not going to have negative income, right? At least we shouldn't for the entire tract. So we'll have make the middle of that scale the mean instead, the overall mean. And then we'll be able to tell which census tracts are lower relative to the mean and which census tracts are higher relative to the mean. Okay, so I do that for both of them. I put the legend on the bottom and I make it a little bit wider and we get something that looks like this. Okay, this is just for income, but it's a pretty revealing map, I think, because you can see almost all of the blue is here in the Portland region and everything else is red, basically, relative to that. I mean, there's a few other areas of blue, but you can see most of the income is concentrated here, which makes sense. Okay, we can do the same thing now for education, but I've just filtered where the variable is obtain instead. Everything else is basically the exact same. And we get a map that looks like this, which is interesting. And so then we can put them together. But if I were to put them together like this for an actual plot that I was trying to present in a journal article or whatever, I'd probably use 2 different color scales. I probably wouldn't keep them as the exact same color scale because that's going to probably confuse people and make them interpret them as being the same variable when they're actually different variables. Okay. I would also consider stacking them vertically rather than putting them horizontally. Okay. The other thing is, for whatever reason, this estimate, like when you have the color scale like this, it always ends up being below that. So you can put an extra line space after that and that'll bump it up. Questions on this part so far? Okay. This part is very much more of a exposure part versus we're going to go really in detail on this. I have the slides with quite a bit of detail because if you want to come and do this on your own later, you can. But I'm going to go over it relatively quick because I don't think it's the most important thing. I do think it's a really neat thing and it's a newer thing. There is an R package to do this for you, but I have not had a whole lot of success with it, so I did it more manually. But there is this idea of if we have this thing, income, and we have this thing, educational attainment, and we think they go together somehow, maybe we want to kind of see the correlation between them, and maybe we can do that through combining color scales, right? And so that's what the idea of this bivariate color scale is. We have a color scale that is built off of 2 variables instead of 1. This is an example. This is one of my favorite examples. So regional income inequality. So you can see as we go this way, this deeper color of red is higher inequality. As we go this way, this is higher income. So this really deep blue is high income, low inequality, right? This deep red is high inequality, low income, right? And then these values kind of mix between there. And so you can kind of look through here and see there's quite a few places like all the way through here, all the way through here that are both high income and high inequality, right? And if we look for places that are high income and low inequality, we can see they're mostly in this region. Okay. So I think this is a really neat way of doing it. It's basically splitting a blue and red and then combining them to get these purples to have this gradient that matches both variables at the same time. And in this case, they annotated it with additional things like this that I think really help too. High income and high inequality, right? So there's a bunch of different ways to do this. This is one way, all right? Like I said, there is an R package to do this, but I haven't been super successful with it. It's been a while since I've tried it, so it's possible it's gotten better. So that might be worth looking at. But the basic idea is that you're going to take a continuous variable and you're going to break it up into categorical variables. So rather than 0 to 100, you have low, medium, high, right? Then you do that for both variables, and you assign the combination of each of those of value, a color value. So low is one value, low medium is a different value, low high is a different value, medium low is a different value, medium, etc. Okay. But you got to be very careful to make sure that those colors actually make sense, that they go together in a way that visually appears that way, right? So it's essentially color mixing is all you're doing, but you have to have two basically categorical palettes that are, or not categorical, sorry, two sequential palettes that go together to make clear categories as well. Okay, so I think this GIF is really nice. There, this part's, whatever, but it gives you the idea. Okay, so this is fairly quick again. So what we're going to do is you can also, this is just another aside, with get ACS, you can also, by default, it was in that longer format, right? But you can also specify that you want the output to be wide instead, okay? So I say output equals wide, and then we'll have a different column, one for med income and one for ed attain. Okay, one column for each of those. All right, then I'm going to remove missing data again, since I have that same issue here for whatever reason. And then I can start to work with this. So what I'm doing first is I'm creating this ed quartiles, where I'm going to cut ed attain from 0 to 1 with a length dot out of 4. So we're going to have quartiles, right? Bottom quartile, bottom 25%, 25 to 50%, etc. And then I'm doing the same thing for income quartiles. And these end up being our cuts, okay? So then we're going to cut ed attain. So notice because we went wide, it's now no longer ed attain, it's ed attain E, because the E stands for estimate. There's also ed attain M, which stands for ed attain margin of error. Okay, so we're going to cut ed attain into these quartiles, and we're going to cut med income, median income, into these quartiles. Okay, and then we end up with something that looks like this. So here's our categorical education. Here's our categorical income. All right, so these are split. Now, finally, I'm just going to count the combination of those two things, right? And then I'm arranging by them. And that count just gives me this with the ends, right? You can see how many of them I have with each of those combinations. And then I'm just going to go ahead and make my palette right there. So I'm saying, okay, mutate pal, making a palette is equal to these values. Okay, and these values just end up being that color scale we just looked at. Then we can join that. So this is now a different data set. We can actually join this back with our original data frame. So I'm joining wider with PAL, and that means now every combination is going to have that color associated with it, right? So then I'll do geomsf, fill is equal to PAL, the color is equal to PAL, guides fill equals none, color equals none. But then I'm going to do scale fill identity and scale color identity. Okay, and we end up with something that looks like this. Notice we do have some missing data right here. So maybe that is the pieces I was missing. It probably is. But you can see the different colors. That looks cool, but I don't actually have a legend. So what we can do is we can actually just take that PAL thing I had before and actually just create a legend for it. So I'm creating a legend by just literally creating another plot. Okay, I'm putting cat ed on the x-axis, cat inc on the y-axis, and then geom tile, basically a heat map, right? Scale fill identities, chord fixed. And then for my labs, I'm doing this expression so I can get this actual arrow down here instead of like, you know, something that looks like this. And that's it. Okay, so here's my little legend, which is another plot. And then I'm just going to use my, you know, I could use patchwork or whatever, but I had more success with maps using cowplot instead of patchwork to put these together. So I'd go GG draw plot, my bivariate map plus theme void, and then this is like the margins around it, and then draw plot my legend, and then this is like where I want it to be. Okay, and it ends up looking like that. Okay, so again, this is like not the most important thing, but it is one of those things that I have seen more and more often, and I think it's pretty neat. I think it's an interesting way of showing two variables at the same time. I've also seen things that are similar to this that are showing maps like this that are with the margin of error on them. So basically they're using transparency to sort of fade out according to the margin of error. And that's really nice too. The thing is with those, you have to be careful. Like it can't just be, you know, alpha equals standard error, margin of error or whatever. It needs to be more careful than that. And I have not quite figured out how to do that systematically. So anyway, okay, we only have about 10 minutes left today. So I'll just talk about TMAP a little bit here. And then the rest of the slides you can have for reference. And please do get in contact with me between now and next week if you want to check in on anything for your final project or anything that you would like to tune up. Okay, I would be more than happy to meet with any and all of you. Okay, so as is probably pretty obvious, I mostly use ggplot, but tmap is really nice and very powerful. So here's an example with tmap where initially I don't think it looks as nice, right? We can say library tmap, and then it builds up just very similar to ggplot. We go tm shape wider, so I'm using the wider one. You could still use your other one, and that would be fine. And then I'd say tm plus tm polygons at attain, right? By default for me this year, it wasn't last year, it was putting the legend like right on top of the map and it was hard to see and it was odd. So that's why I add this tm layout legend.outside equals true. So that puts the legend out here to the side. Notice by default too, it also actually takes a categorical approach to this. So this is a continuous variable, but it just goes ahead and cuts it anyway into a categorical variable and plots it. Okay. You can facet as well pretty easily. So census vowels, tm polygons, put estimate, right? Estimate is what it's going to fill by, plus tm facets by variable. So this is my longer one, right? And then tm legend, adjunct, oh my gosh, legend.outside equals true. That's going to put it here. Okay. So these are pretty standard basic maps, but they are much faster than the ggplot ones. So that's nice. Okay. You can change the palette pretty easily as well. So I have editain that I'm filling by for the polygons, and I'm saying the palette is equal to magma, right? And then the border.col is gray 90. So you can see we've got this like gray borders for all of these, but the fill is magma, which is from the Viridis, right? And then LWD stands for line width. I think you could probably just say size there too. And legend.outside equals true. You can also make the legend continuous if you want to. You just say style equals CONT for continuous. All right. this one works for me on my local, but not on my slides for whatever reason. I have no idea why. But if you do get ACS, and we're going to do county level this time instead, and I'm just going to do editing. But if I grab county level data for the educational attainment, then I can plot that by actually annotating the county name on my plot. To do that though, I want to also know where I want to put that text. And so that this function comes in quite handy. st_centroid, right? It's going to find the centroid, like the center of a polygon, as much as it can. Okay, so we say county. County is the entire data frame, but when you do that, it's going to know you want to find the centroid for each geometry, each row. Okay, so these are the centroids. And instead of, so back here, this is like Deschutes County, Oregon, Benton County, Oregon. I want it to just say Deschutes, Benton, Curry, Union, Sherman. I'm going to delete all the rest of that stuff, right? So that's what I'm doing here. Getting rid of County, Oregon is going to be nothing. Okay, and then this is the code that does work for me locally, but for some reason doesn't show up on my slides, and I can't figure out why. But we're going to do TM shape county, then TM polygons estimate, right? That's going to make the fill based on the estimate. I made it continuous again. And then I just say plus TM shape centroids, okay? And then plus TM text county and size equals 0.5, and then TM layout legend outside. That on my local puts the actual county name onto each of these too. Okay, let's see. I'm running out of time, so I'm not going to do that locally. Okay, I'm going to leave this for later. You can add raster data if you want. This is like a default color palette. Change the custom palette. I think this is just kind of a neat palette. I just created on my own, but because you can see volcanoes very easy. So that's kind of cool, I think. Anyway, this, you can do a bunch of stuff with TMAP. This is straight from TMAP, and it looks like something you would have on an elementary school wall, right? There's a lot of really cool stuff you can do with TMAP. If you go to the documentation, let's go real quick. TMAP. Let me do it like this. TMAP R. There we go. Thematic maps in R. These are all like this is an interactive map, right? Like you can do all sorts of stuff. So it's a really powerful package, really neat stuff that you can do. The last thing that I'll mention here, and then we have 5 minutes left, and so I'll just either wrap up or take questions if there are questions. But all you have to do here to change this, to make it change it from a static map to an interactive map, is just say tmap mode view. And then when you create your map, you'll get an interactive map like this. And this one actually shows the counties. All right, so this is just like my other code, but for some reason, this one, the counties actually work. And it's pretty neat because you can do a bunch of stuff, right? I can click on it and it'll tell me the estimate. I can also change this to something else. I can take off layers, right? And pretty simple to do all of that. Zoom way out too. Okay. And then interactive maps. I've mentioned this with map view is very simple way to do this. Library map view county. There it is. There's the interactive map. It tells you a whole bunch of stuff. It tells you basically everything else that's in the data frame. So that's cool. You can also tell it to color something. So the Z color, right? What like up, right? What color should it be? And then again, you can change this to different things if you want. And then same. And then last thing, yeah, you can also change the pop-ups. So then in this case, it just tells me the name is Deschutes County and the estimate is that. Okay. Pretty neat. All right. Let's pause there. So we have 3 minutes left. So I know that this is a lot. As I said, today is really partially about exposure and partially about practicing. I know quite a few of you were trying to do maps and stuff for your final project, so I apologize that it took us so long to get to this point. It's kind of difficult to figure out pacing of different things because we also needed to get to like the dashboards and blogs and stuff too. So if you start to go through these slides more on your own and you have questions, please get in contact with me. Next week we'll be in Headco 142, I think it is. 142, yep, Headco 142. Any last minute questions or things anybody wants to check in on? Okay. Well, thank you all. I look forward to seeing your final projects next week.